Okay, everyone. So I am going to share my screen now. And I'm looking at today's class, which is Monday, October 4th, class 6. And what I want to do is you had the horizontal quiz already. I want to go over that. I want to review the schedule, talk a little bit about the exam, and then move on to our huge problem that we're going to be working on, which is traverses. So let's look at the schedule first. And here's the schedule. Remember, we did all the geometry and trig review, intro to engineering, intro to surveying, distance measuring, leveling, and you had your exam. And last week after the exam, when I taught angles, bearings, and azimuths, that's the beginning of the second section of the course, when we'll have our second exam. So angles, bearings, and azimuths from last week are included in the second section of the course. And today we're going to be looking at traverses and then moving on to compass and meets and bounds and such in the future. Okay, so and now we're going to look at the traverse class problem, and that's on page 26. So I'm going to go up. Where do I find the packet, you guys?
In module 0.
And right, in week 0. So I'm going to open that up. And I'm going to open up the lecture packet. And we're going to be working on this problem a while today. Oh, actually, would you guys like to take a break right now and then come back? Yeah, okay. Some of you I know are coming from my previous class that ended at 5:30. So it's 6:42. Let's let me stop sharing. Let's take a break and return at 7 p.m. So that'll give you about 15 minutes. And in the meantime, I'll check that quiz. So I'm gonna pause the record. Okay, so we're gonna work on a traverse class problem. So what a traverse is, it means that it's a closed loop. And why do we have closed loops? It's always so we could check ourselves. And in surveying, you know by now how important it is to make sure that we're doing checking as we going along. So this is data that was obtained from a surveying crew, but some of the information is omitted. So we're going to go through steps 1 to 5 and find a bunch of different information. The first one says, compute the interior angle at point A. So let's take a look at the traverse first. So typically, in surveying, now, we go clockwise. So starting at A, going from A to B, I have the bearing of line AB, and I have the length of line AB. And then at B, I have, let's see, Olivia, you're up. What is this angle? What type of angle is this?
An interior angle.
Interior angle. Then going from B to C, I have the distance. And Reese, what kind of distance do you think this is? Remember, there are 3 different kinds. There's horizontal distance, vertical distance, and slope distance. So what do you think the distance is?
It's probably a horizontal, isn't it?
Yep, it's horizontal. And the reason why is because as surveyors, just like in taping, we always measure horizontal distance. The slope can change over time, right? You have a piece of property that has a down slope. The horizontal distance really doesn't change. Well, of course, if there's an earthquake, yes. But the horizontal distance doesn't change. What changes over time is the slope distance. So if I have a piece of property like this, regardless of whether I put a retaining wall here and fill this with engineering fill, my horizontal distance is always going to stay the same. So the distance that's given on plans is always the horizontal distance. So you notice we're given the horizontal distance from B to C. We're given the horizontal distance from C to D. We're given the horizontal distance from D to E. and then the horizontal distance back from E to A. But we're only given one bearing from A to B. But as Olivia said, we're also given angles, and they're interior angles. So notice there's an interior angle at B, an interior angle at C, interior angle at D, and an interior angle at E. So the pieces that are missing is we don't know the bearing of this line. We don't know the bearing of that line, the bearing of this line, bearing of this line. And we don't know what this interior angle is here at A. Okay, so let's talk about what we do know. When I have a triangle, Roberto, when I have a triangle, what is the interior angles total up to be? So A, B, and C, it all totals up to be what?
180 degrees.
180 degrees. All right. What if I have some rectangular figure? Tarek, A, B, C, and D. What is the angle here? And I'm talking about the interior angles.
Let's see, some of the interior angles, I think it's number of sides minus 2 times, I forget the
Actually-
formula, I'm sorry.
Very good, Tarek. That's where I'm going, but we're not
Yeah.
there yet.
Okay,
For a rectangle,
oh,
what is it? What is it?
360?
360.
Yeah.
Okay, so these two things we know, but as Tarek was mentioning, there is an equation that if you're given, if you know the number of sides and n is the number of sides, you could you could calculate what the interior angles are. So because we know this, we know with 3 sides, it's 180, and with 4 sides, it's 360. I want you to figure out what the equation is. Don't look it up. Try to figure it out. Here we have n, is 3. N is 3, and we have 180, it totals 180. And here we have n is 4, and it totals 360. So what is the magic number? Can you figure out what the equation is? So somebody might say, oh, well, maybe it's 60 degrees times n gives you 180. That's not right. There's a minus in there somewhere. Because if this was the case, then 60 degrees times n, it does not equal 360. So this cannot be the equation. I believe in you. You're going to come up with the equation. Give everybody, 5 minutes to think about it and come up with an equation. Anybody think of it yet? Okay, so it can't be something like x times n is equal to 180, right? Because then that would mean that x times n would equal 360, and it doesn't. So we know it can't just be multiplying a number. So it's n minus something. So n minus x times something is 180, and n minus the same number equals 360. So what do we want on the left side of the equation to get, if this is 3, what does X need to be here in order for us to get? If I have 3 here, I have a control of this X and I have a control of this. Nobody wants to take a stab at it? Tarek, you want to tell me?
Yeah, it's n minus 2 times 180.
Yep. N
I
minus
just
2.
remembered it.
Yeah, good. N minus 2 times 180. So does that equation make sense? So N here is 3. 3 minus 2 is 1. 1 times 180 gives you 180. How about here? N is 2. N is 4. 4 minus 2, it's 180 is 360. So if we have a 5-sided figure, which is what we're given here, N is 5, what is the interior angle going to be? So when N equals 5, my interior angle is going to be N minus 2 times 180. So it's going to be 5 minus 2 times 180, which will come out to be what? 540 degrees. Is anybody here? Are you guys here? Talk to me. I feel like I'm just talking to myself. Everybody, could you show your face and not just show your photo? Okay, so now we know the sum of the interior angles is 540 degrees. Let's check out how am I going to calculate A? So what is A equal to? So Jose and Beth and Jorge and Tarek and Connor, thank you for letting me see people. Okay, and Amani, you're next.
So to find the angle, we just add all the angles and
Okay.
say 540 minus the sum of the angles that we already have.
Okay. So are you finding it, are you guys pretty comfortable adding all the degrees, minutes, seconds? 105 degrees, 15 minutes, 86 degrees, 56 minutes, 82 degrees, 48 minutes. And I know a lot of you already know how to do it on a calculator, so you should be good at it. 31. Oh, the horizontal angle. I found there was an answer that was wrong on the quiz. So everybody moved up a point. It was the azimuth to a bearing. It was supposed to be east and it was west, or there was some error. I can't remember now, but everybody's fixed now. Okay, so what did you get as the total?
I'm still adding it up.
Okay. Ashton, did you get the total yet?
No, not yet.
$334.30. Did somebody get that? I just did it by hand.
I got a 434 degrees, 30 minutes.
Yeah, that's what I got.
100. It's yes, I left off the one. Thank you. 430, 430. Good. And then we know it's 540 degrees. Right? And then we subtract 434, 30 from it. $105.30. Anybody get 105.30?
That's what I got. Yeah.
Okay, Roberto too. Okay, great. All right, so the first step in this was to actually look at what is given to us. And we're given 4 of the interior angles. We now know what the equation is for finding the interior angles, knowing the number of sides. So n represents the number of sides. So we were able to determine what the total inside interior angle should be, and we added them and subtracted them to find out what A is. Okay, the next is to compute the bearings of line B, C, C, D, D, E, and EA, and then check the bearing of line AB. So this is going to be good practice from last week's horizontal. So I'm going to start out by drawing point A. And I'm going to draw my coordinate system at A. And A goes up here to B. And certainly if I wanted to draw it on AutoCAD or draw it to scale, that would be helpful because we could actually measure it too. Could everybody see my page, or let me make sure I'm still pinned. Yeah, I'm still pinned, so. North, south, east, and west. And we do have the bearing of AB, right? It's north, 53 degrees, 49 minutes, east. Okay, Connor. Wait, Beth, did I already ask you a question? I'm going to go to Beth. Beth, if it's northeast 5349, where do I put that 5349 degrees?
It goes like in between the north and the line.
Right. So it goes in between the north and the north axis and the line. So right here is 5349. So that means then this right here is 5349. Everybody agree? Make it a little bit bigger. Let me just. Okay. And then what do we know about the interior? So now I'm at Connor. What do we know about the interior angle? I'll bend this sheet so we can work on it. What do we know about this interior angle here?
That it's 105 degrees, 15 minutes.
105.15. So let's draw this to C. And I know this whole angle here is 105.15. So then what is this angle, Connor? It would be 105.15 minus 53.49. And what does it turn out to be? What is this angle here? 105.15 minus 53.49. Connor, I'm going to have you continue doing that.
I'm putting it in right now. One sec.
Okay.
I got 51 degrees, 26 minutes.
Okay. So we got it to be 51 degrees, 26 minutes. But now the question is, I'm trying to find the bearing of this line. So what would the bearing of this line be?
It would be south 51 degrees, 26 minutes east.
Yep. Okay. Okay, so now I'm going to draw my next north, south, east, west. You could see how it's much better if you're drawing it large, right, than really small. You could really mess up on the numbers. Okay, and this is going to go down to here. And in this case, we were given that the interior angle here at C is, so we know that from here to here is 86 degrees, 56 minutes. Well, where do I, so Dan, where do I transpose this 5126 that we got here? Where does it go down at point D? C, sorry. This 5126 that I just calculated, where does it go? Over by C. Dan might have said that.
Up between the north and the line, the
Correct.
5126.
So right here is 5126. But what I'm trying to find is I'm trying to find the bearing of this line, right? I know this is 5126. They gave me that the interior angle is 8656. So let's keep Edgar. What angle, where do I need an angle so that I could figure out what the bearing is?
We would need an angle between, I believe, south and the line, right?
That's right. I need the line, I need this line right here. And how would you calculate that, Edgar? So I know this interior angle here of 8656, and I know this angle right
Oh,
here.
okay, my bad. I didn't see the 8656.
Yeah.
So I would add up the 5126 and the 8656 and just subtract it by, well, the number that comes out subtracted by 180.
Great. So this angle right here is going to be 180 minus 5126 minus the 8656. And what did you get?
I'm still working on that one. Give me 1 second.
Okay. And it is best to draw this to scale using protractors and using distances, because if you draw it all to scale, then you could check yourself visually. You know for sure that you're supposed to be going in the southeast direction or southwest direction or whatever. Yeah, Jorge, no problem.
I got 46, 37.
For it's going from C to D. I have something different. Did somebody else get something different, or did you get what Edgar just got?
I got south 41 degrees 38 minutes west.
Yeah, that's what I got too. Edgar, so check your math. So it's it comes out to be 41 degrees 38 minutes. Okay, so now Joanna, because we now know this angle, we calculated this angle, what is the bearing of line CD? And remember, we're always going clockwise, right? So what's the bearing of line CD?
Would it be south 41 degrees with 38? Maybe it's west.
Yep. Okay. So I want you guys to get in practice, and a lot of you do this, to like say the answer without making it a question for me, right? You know a lot of this stuff, and I want you to say it to me. And if you get it wrong, it's no big deal, because we know when there are failures, we learn something. So if you get it wrong, no big deal. The goal is to learn something. I don't want questions, because when you transfer, I want you to be talking like you mean it. All right. Okay. So next, now it goes up a little. to E, and I'm given this angle is 82.48. Okay, so, Jose, no. Yeah, Jose. I calculated this 41 degrees, 38 minutes right here. Where is it at point D? I'm drawing my axes again. North, south, east, west. Jose, where is it?
Would it be it's between the north and the line?
Yep, it's between the north and the line because this is equal to this. So this angle right here is 41 degrees, 38 minutes. Great. Lori, so how can I now determine the bearing of line DE?
You would, let's see. You can subtract 41 degrees 38 seconds from 82 degrees 48
Minutes, yeah.
Sorry, minutes.
Yes.
And then take the remainder and subtract it from 90. Oh no, because you need the north. Sorry.
Right,
Yeah,
right.
so that's it then.
Yeah, so this is what I would do. I would look at this line DE, and I know it's going to the north, so I put the north. And I know it's going to the west, so I put the west. So I know I have to find it between the north and wherever the direction it's going. So I need this angle right here. And that angle is going to be 82 degrees, 48 minutes minus 41.38. And oh, something that I saw a few of you did on the exam, always work in degrees, minutes, seconds. Don't go back and forth. When you use decimal degrees, you make rounding errors. We use degrees, minutes, seconds for a reason in civil engineering and surveying. So never convert. Okay. So subtract these two, it comes out to be 10.14. Is it 41.10? So then I stick in the 41, sorry, the 41.10. And then my last line goes back up to A. I'm off a little bit. So it's going from E to A. And Mackenzie, you're next. So I have this 41.10. Let's at E now. I'm going to draw an XY. I mean, sorry, a north, south, east, north, south, east, west line. And Mackenzie, where does this 82.48 go on here? And actually, I'm going to erase this so that we have a little more room because I'm getting a little cluttered here. So this bearing here we got as 41 degrees, 10 minutes, and it was going north west. So I have this 41.10. Where is it at point E? Where do I see the 41.10, Mackenzie?
You see it like right above the E, or
Okay, so you see this angle right here, right? And if
Yeah,
I
that's
wanted, I
the
could
40.
bring it down here. This is where it is, right here. Is that 41? So if it's right here, where is it?
Can I pass?
Sure, it's alternate interior. If it's right here, then it's here. You see how it's alternate interior? When you have two parallel lines and you have a line that intersects, when you have two parallel lines and you have a line that intersects, this equals this, and they're called alternate interior. Okay, so it's the same kind of thing here because we have two lines that are parallel and this intersects, so this must be equal to this. So this right here is 4110 as well. Okay, Olivia. So if I'm trying to find the bearing of this line going from E to A, how do I find out that bearing? What do I need?
You need the degrees from the north to the line going to the left.
That's right. So right in here, I need. So what is the bearing of that line? Is it going to be north or south?
North,
And is it east or west?
west.
West. Okay. So that means we go from the north, that's going to be, and we're going towards the west. So we need to find this. We know this. So how do you want to find it?
I was thinking to do 90 minus 41 degrees, 10 minutes to
Okay.
find,
So that would be, then we would find this.
yeah. And then add another 90 degrees to the one we just found.
Okay.
And then subtract that from the 159 degrees, 31 minutes.
Okay. Where's the 150? Oh, I didn't draw what this angle is, right? Well, we don't have to put that in, but we'll put it in. 105, 30 minutes. Okay, could you tell me again, what's the 59? I'm not sure what you
It's
meant.
the E angle is 159 degrees, 31 minutes, the interior angle.
Oh, the E. I didn't draw the E in yet. I'm sorry. So this angle right here is 159, 31. Certainly, yeah, I couldn't do it without having some other piece of information. So we have this angle. We could solve for this one by saying 90. So what you did is you took 90 minus 4010.
4110.
4110 to find this one.
Mhm.
And then what did you do?
Add 90 to that.
Then you added 90.
And then subtracted that from 159 degrees.
Great. So we know that this is 159. We know, if we know this, then we know this is, because this is going to be 90 minus this. And if we know this and we know this is 90, we could subtract this. So let's do this now. So this is going to be 50. And this is going to be 89. So this is going to be 48. Is that right?
Yeah, that's what I got.
Okay, and then you're adding 90, so that's 50 minutes, 80, 138 degrees. And now you're going to take the 159.31 and subtract the 138.50. And what did you get? This is 9, this is 8. This is going to be 204. I think it's 2041. Let's take a look closer at this. So we're given this 159 is the interior angle at E. Let me put it on. And then I know what this angle is from here, and it's 4110. And what I need is I need this angle right here. So Olivia took 90, this 90 minus the 4110 to get this little guy in here. The little guy is yellow. Once she got the yellow, she added 90 and then subtracted, because 159.31 minus the little yellow guy minus 90 gives you this blue. And what did you get? Did you get 2041?
Yeah.
Okay. So this angle right here is 20 degrees, 41 minutes. See, even though I did it on a big sheet of paper, it's still like kind of, you can make mistakes, right? Okay. So now we have 20 degrees, 41 minutes, Reese. And now I drew my north, south, east, west line here. where does this 2041 that we calculated to be right here occur up at point A?
It comes in, so it'd be the, what was it again? 20, it would be south 20.
Wait, I'm sorry.
10.
You know what? Reese, I'm sorry. I skipped a spot. I skipped a part. Olivia, why don't you finish it? So you said that we needed the 2041, right? So the
Yeah.
bearing of line EA is northwest,
20 degrees 41 minutes.
right? I forgot to put that bearing in. And then now Reese, we're back to, this is 2041. So where does this angle lie up here?
What, it lies just to the left of the, or it's right. It's hard to explain where it is.
Well, it's
Southeast,
between what and what? Because an angle always has two lines. Which
South and
lines is
east.
it between?
It's between south and east, if that's what you're asking. That's where the
South,
20 is.
south of
Yeah,
the
right there,
line,
right there,
right? Okay.
Yeah.
So this is 20 degrees, 41 minutes. So this angle here is the angle between the south line and the line in question.
Joanne,
Yeah,
I think you wrote the 105 at angle A. I think you wrote that when we were doing E. I don't think that's actually that angle.
okay. Okay, hang on a sec. Thanks. Okay, so let's see, the interior of A, we calculated already,
Oh, you
and
did?
it's
Oh, okay.
105.30.
Oh, okay.
Yeah, 105.30. So I put that there. Okay, and we didn't even need this in the end. I mean, we needed it to answer the first question. So what we did now is the first question asked how to find the interior angle at point A, which is missing. So we had all the other interior angles. We used this equation and we found out what the interior angle was at A, which is 105.30. Then, given the bearing here and knowing all these interior angles, I was able to find the bearing of all the lines. Okay, so the second question was compute the bearings of line BCCDDEEA. Okay, and it says check the bearing. So we did one. Let's check the bearing for AB. And in that case, in order to do the check, we definitely want that 105. So who we at now? Roberto. So I moved this 2041 up to here. And I also know I was given this 5349. But this is our bearing and they want us to check the bearing. So what we calculated, remember indirect and direct measurements? We have the 105.30 and we have the 2041. So what should this bearing, and I'll do it in a different color. What should this angle be? How would you calculate that angle? Roberto? So we have this and we have this and we have this and we have this. Here's the straight line, right? The north-south line. We just calculated the 2041. We calculated 105.30 before, and now we're trying to get this value right here. So how would I calculate it?
You add up the 105.30
105.30.
with the 2041.
Great. And then what do
and
I
then
do?
You subtract that by 180.
Great. Okay, and what do we get?
I'm checking.
Okay.
I got 53 degrees, 49 minutes.
53 degrees, 49 minutes. Awesome. And that's what the bearing was here, right? And wouldn't it make sense that if it's 5349, which we were given, then we do have the right bearing? So everything checked out. Does anybody have a different way of doing it where I like to draw all the axes around here as I'm moving and just keep keep moving the angles? Has somebody thought of another way of doing this? Or are the axes helpful for everyone?
I like the axes.
Okay,
Yeah, I like the axes too.
okay. All right, so let's go on then. Let's see what sheet. This is sheet 1. This is sheet 2. Okay, and this was A, and this was B. Okay, so now let's go to C. Question C says, compute, oh, it's not A, B, and C, it's 1, 2, and 3. Sorry, let me do that over. 1, 2, and 3. Okay, the next question says, determine the coordinates of all the points with an assumption that A is 0, 0. And then we have to determine the closure error. Okay, so let's start with coordinates now. I think I might, should I, I feel like it might be good if it was a clean drawing. Let's draw it over. Okay, I'm going to write the bearings of each line. North, 53 degrees, 49 minutes east. This one is 51 degrees, 26 minutes east and south. This one is south, 41 degrees, 38 minutes west. This one is north, 41 degrees, 10 minutes east. And this one is north, 20 degrees, 41 minutes west. So this is the bearing of each of the lines. And I'm going to go back and I'm going to draw my axes again. Okay, north, 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 north. Draw them a little darker. Okay, so Tarek, can you tell me again where this 5126 is here?
So the way I think about it is if we extend line BC past the y-axis, it will be, let's see, south 51. Yeah, it will be from the north down to that extended line, I believe.
Okay, good, but actually the best thing is, well, let's talk about the process first. Let me go back.
Just to clarify, are you asking where point B is?
No, I was asking where this 5126 is. And he said you could just
Oh, okay,
extend
gotcha.
it, and you can. But let's go back to let's talk about the process first before we start doing this. So we know what the coordinates of A is. It's 0, 0. And let's think in terms of coordinates. So for us, coming from math, X to us is first, right? Right? Wouldn't we say that this is XY? But we're not working with an XY coordinate system. We're working with, here's our X, here's our Y, right? But what coordinate system am I really working with? I'm working with a north, south, east, west coordinate, right? So we're all comfortable coming from math, knowing that you say X first and then Y, and X goes in the positive X direction, Y goes in the positive Y direction. The negative X is to the left and the negative Y is going down. But now we have to talk like civil engineers and surveyors. As civil engineers and surveyors, we don't use X and Y. We use what's referred to as northing and easting. So
You got your east and west
what?
swapped. You got your east and west swapped on the.
Oh, thank you. Thank you. So Tarek, in terms of northing, if we're using these coordinates like the XY in math, which one is first? Is it the north or the east?
I would say the north. The north.
No, if we're relating it back to math, we represent the east and then we
XY axis.
represent the, if we are setting up a coordinate system like math,
Okay. So north corresponds to the y-axis, east corresponds
That's right.
to the x-axis.
right? So
Yeah.
the x-axis, the positive x-axis happens to be east and the positive y-axis has to be north. So the negative x-axis corresponds to what? Tarek?
West.
West. And the
West.
negative y-axis corresponds to what?
South.
South. Is everybody comfortable with that? We come from a place of math, knowing X is reported first and then Y. If we use the parentheses, we have to remember that X is east and X is east and Y is north. Although there are times in surveying that we actually talk about northing and easting. But if we're using coordinates, we have to remember that this is east and this is north. So now, if I know what the coordinate is here, oh, and let's put the length too. We know it's 567.34 feet. We know that this is 810.76 feet. This one is 922.75 feet. This one is 411.72 feet. And this distance is 588.16 feet. So if we know the coordinate of A, and they're asking us to find the coordinate of B, and we know the bearing, and we know the distance, couldn't we use a trig function to find the new coordinates? So Amani, so going back to Tarek, what you meant when you were talking about extending this line, that is true. But since we're trying to go from this point to this point, I would rather stay within the triangle that we're looking at. I want to stay inside my traverse. I don't want to go to some angle out here. So Amani, with the 5349, where does the 5349 go in my right triangle right here?
It's that the oh wait, can I actually I'm having a hard time explaining. Can I use the annotation thing?
I don't know what you mean by annotation.
Oh, well, it's gonna be at point B.
No, do you mean like something you could write on the screen?
Yeah.
Yeah, go ahead. Sounds fun. So do I have to give you permission or something?
Yeah, I don't think you have it, but it's okay. It's at the point B.
Okay, but where? There are so many.
Inside the traverse.
Okay, let's start at A because that's where we're coming from. So where is the 5349? Between what and what?
Between north and the line.
Right. So right here is my 5349, right?
Yep.
So that means right here is my 5349. Right?
Yep.
Okay. So if I know this angle and I know this hypotenuse, can I calculate, if we want to talk about it in math, the change in y and the change in x getting from point A to B? And that would really be, let's just talk about it in terms of x and y right now, because you guys are very comfortable with math. So how can I find these values of change of x and y? So let's see, I'm on page 3. So I'm going to page 4 now. So I have this triangle right here. So how can I find, going from A to B, how can I find what the change in x is? Amani?
I'm not sure. I don't see
Okay, so
what.
okay, so let's highlight this. Let's get my highlight. I have a triangle here. And it's a right triangle. And you told me that because this is 5349, this angle right here is 5349. And I know the distance along the hypotenuse. So if I wanted to find delta x, the change in x, would I use, it's a right triangle, so I'm probably going to use sine, cosine, or tangent,
Yeah.
right?
Yes.
Okay, so give me an expression that relates the change in x and this hypotenuse distance.
Oh, tangent?
Well, I have the angle, I have the hypotenuse distance, and I'm trying to find delta x. Here. Drawing another angle, another triangle. It's a right triangle. I have 53 degrees, 49 minutes right here. And I know this distance is 567.34. And I want to know what change in x is, which is this.
I just can't see it.
Okay.
I'm stuck in like this, the sine and cosine and tangent.
Right. Okay, so Ashton,
Yeah.
how do I find change in x? What am I using?
I use sine.
Okay, so let's see. The sine of the angle we know, which is 5349, is equal to delta x over the 567.34. So that means delta x is equal to 567.34 times the sine of 5349 feet. And what does delta x turn out to be? Ashton?
I got 457.91 feet.
Let me see if I have the numbers. Hang on a sec. Yeah. Yep. 457.94 feet. Amani, you got it now?
Yes, I was looking at it in a completely the opposite way.
Okay. All right. So here's my right triangle. This is the hypotenuse, and I'm trying to find these two sides. Okay. Let's do, Ashton, you want to do the other one? Or Amani, you want to do delta y?
I mean, yeah, now that we have delta x, we can do the opposite over delta y over delta x.
Yeah. However, You never want to calculate something from something else calculated if you could avoid it. And
Okay.
instead do a check. This is what we have, and this is what we have. Use what we have to get delta y. So what is it? Delta y is equal to?
We can just use cosine, right?
Right. So it's fine. I'm just doing it shorter rather than doing it in 2 steps. Times the cosine of 53.49. And delta y turns out to be 334.91 feet. And now you could do your check if you want. You know, the check, there's a couple of checks. So one you said is, let's do the tangent of 53.49 is equal to delta x over delta y, and tell me if you get the right answer. Do you get it? So delta x is 457.94 over 334.91. And does it check?
I'm getting different last decimal places, but I don't know if it could just
Well,
be a
remember,
rounding thing.
we're rounding, but it's coming pretty close.
Yes.
Yeah.
Okay, so this is one check. Beth, could you think of another check we could have done?
We could do delta x squared plus delta y
Yep.
squared equals
Delta x squared plus delta y squared
hypotenuse
equals
squared.
567.34 squared. So try that out too. And see if that works. So let's do it like we do in statics. We'll put the check mark and okay at the end. Did somebody get it to check? Is somebody checking? Come on, you
I
guys.
got it.
Okay, every one of you has a calculator. Pull it out. All right, so now let's take a look. We're going to go, we know we're going from point A to B, and we're using trig, but let's take a look at this. If the line goes from A to B, is it going in the positive x direction or the negative? Connor.
Positive?
Positive. Was that a question?
No.
Good. When we go from A to B, are we going positive or negative in the y, Connor?
Positive.
Positive. Great. And we did 2 checks. Okay, so now we're going from B to C. So let's draw B to C. B is here, goes down to C. It has a south 51 degrees, 26-minute east. And it has a distance of 810, oops, not a degree, 810.76 feet. And so here we are on the next one. We're going from B to C. We have south 5126 east, and we have 810. And now I'm going to make another triangle. And here's my right triangle, and here's my delta y, and here's my delta x. So I'm going to give you just a couple of minutes to write out the equation for both. Delta x is equal to what? And delta y is equal to what? So the first thing to think about is where in this triangle is the 5126? Dan, where's the 5126 in this triangle?
It is between the call it the y-axis, I guess, and the line.
Right, so it's right here. That's 5126. So we're using the bearing, drawing a triangle from the point I'm going from and to, and then finding where the bearing is inside this triangle. So Tarek, do you see how, because we're using trig, I wouldn't want to find an angle outside?
Yeah, I saw my mistake last time.
Okay. All right, Edgar? How do I find delta x?
It's pretty similar to the other one, right? We would use
Right.
sine.
Yeah, sine. So it's 8, 10, 76. It's the hypotenuse times the sine of 51, 26.
126.
And y is the cosine. So it's 8, 10, 76 cosine of 51, 26. And I got from B to C, I got the change in X is 633.89 feet, and the change in Y I got was 505.48 feet. Did somebody get both of them?
I got that.
You got them? Okay. So now,
Slightly
but let's,
different decimal, but I think it's close enough.
well, what did you get?
I got 633.32.
633.32?
Yes.
Oh yeah, that's not close enough. So it's either my mistake or your mistake. So somebody else check the numbers.
Joanne, I
got 633.92.
Same.
That's what I got.
You got 9.2?
Yeah, and then for the delta y, I got 505.45.
Okay, so that would be closer to being off, Lori, okay? Let's just keep my numbers because all my notes are in the packet and they relied on these numbers. So let's just keep it for now, okay? Everybody cool? Huh?
Yeah.
Okay. All right, so now we're going from B to C. So is the change in X positive or negative?
Negative.
Going from B to C.
It's negative.
X,
Positive.
positive, you guys.
Positive.
Going from B to C and the Y is negative. Okay, want to do one more? Well, let's just stop here for a minute and let's just see what this all means. So we have the bearing, we have the distance of each line, and then we have the bearing. So what we're doing is we're looking at this triangle going from A to B because the coordinate of A is 0, 0. So I want to find out what the coordinate of B is. So what I just did is determine what the X and Y is. Then I'm going from B to C. I'm going from B to C. And again, I'm going to determine what the change in X is and the change in Y is. So if we go back, if we're going from point A to B, and we found that the change in X is positive and the change in Y is positive, they asked me for what the new coordinates of B are. What are the B coordinates going to be? Joanna, what is, if A we know is 0, 0, that's the coordinates of A. What is our coordinate going to be for B, knowing that we just got the change in X and change in Y?
Wait, I'm confused.
Okay, so we're given in the problem that the coordinates are 0, 0 for A, right?
Yeah.
Okay. And okay, let's go back for a minute. Does everybody see that this is horizontal? This is a plan view, right? What is this distance? 567.34. This is a horizontal distance from point A to B on the ground. These are all horizontal distances on the ground. They're telling us that the coordinates of A are in X and Y is 0, 0. And now we want to find out what the coordinates are at B. So what we did is we found the X distance from A to B and the Y distance from A to B. And then we're going to find the X distance from B to C and the Y distance from B to C, because I need to find out what this coordinate is. So if I know A has a coordinate of 0, 0, and I just calculated what the change in X is and the change in Y is going
wait.
from A to B, what are the coordinates of B?
So wouldn't your coordinates be the change of X and the change of Y?
Yeah, so give me the numbers.
Wait. I put them in my calculator and I left them there.
Look on the sheet of paper. You could see my screen, right?
Not the bottom. Oh, wait.
What?
I can,
right
yeah,
here.
yeah, never mind. It's 457.94
Right?
and 334.91.
Great. Feet, right? So
Feet,
those are the
okay.
coordinates of B. Okay, so now we know the coordinates of B. And now we just calculated the change in X and change in Y going from B to C. So John, I want you to do it again. So what is the C coordinates now?
So that would be 633.89 with comma negative 505.
Well, remember that the B coordinate now we just learned is 457.94 and 334.91.
So now I have to subtract the.
That's right. Good job. So we have to take the 457.94 and add to it because it's a positive.
Yeah.
633.89, and we get 381.910. So we get the X coordinate of 1091.83. And then how do we get the Y coordinate?
Then that one's 334.91.
Right,
minus
334.91 minus 505.48. And what do we get?
You should wait. -170.57, negative 170.57.
Right. Does anybody have any questions about this? I'm calculating the change in X and change in Y going from one point to another. So now I'm going to the next one. And now I'm going from, let's look at the picture. So C is here and D is down here. And from C to D, it's 922.75 feet, and it's south 41 degrees, 38 minutes west. This is the information for this line. So, Jorge had to leave. Jose, and let's do the northing, and we could do the northing and easting. Well, no, let's do the triangle. So we have a triangle here with the right angle. This 4138, where should I draw the 4138? Is it the angle at D or the angle at C?
Angle at C.
Correct. Was that a question or was that a statement?
No, I could say it with a stronger voice. Angle at
Cool.
C.
Nice. Thank you. Okay, and here's my change in X and here is my change in Y. So, Lori, how do I calculate the change in X? And how do I calculate the change in Y?
It would be 922.75 sine of 41 degrees and 38 seconds.
Yep.
Sorry, minutes.
Yeah, great. So
And then-
always draw the triangle because you're gonna put the angle in. It may not always be sine or cosine. It really depends on where that angle is. All right, and then Mackenzie, what's the change in Y? How do I calculate the change in Y?
It's gonna be 922.75 cosine,
Right, of 41.
41 degrees.
Right. And I'm just gonna use my change in X and change in Y because yeah, I gotta do that. So it's, the X is 613.12 feet. And the Y is 689.60. Hang on, I gotta open the door. Okay, Mackenzie, going from C to D, is delta X negative or positive?
Negative.
Right. And going from C to D is delta Y negative or positive?
Positive.
Going
Negative.
from- Okay. All right. So now we have to figure out the coordinates. So Olivia. So we need to find the coordinate of C in the X and the Y. The coordinate of C was 1091.83 and a negative 170.57. And this is an 8. So how do I find out the coordinates of D?
You would do the CX coordinate minus 613.12
Right? And the Y?
minus 689.60.
Right. And this one. So this is the coordinate of D. And I got 478.71. Positive. Okay, so the coordinate, so the D coordinate was 478.71 minus 860.17. Okay, so now why don't you guys do the next two? So now we're going from point D to point E. And then in surveying, we always want to close. So we're going to go from E to A. And I'm going to come back in 15 minutes. All right, or maybe 10 minutes. So you're going to get the coordinate of E, and then you're going to get the coordinate of A. And I'll be right back. I'm going to, so going from D to E, it's north 41, 10 degrees west. And what is the distance? The distance is 411.72, and we want to find out what the change in X is and the change in Y. So It's 41 degrees 10 from west. And this is north, south, east, west. So where would this angle be? It would be northwest, so it would be up here. So where's the 4110? Somebody, oh, I should call out the name. Okay, who's next? I think we're on Tark. No. Reese.
What was the question again?
We're going from D to E. Where is the 41 degrees, 10 minutes?
The 41 is angle D.
No, it's not. Because take a look. It's going, the line is going from D to E, and the angle is 41 degrees west of north. So it's right here, right? And that connects here. So it's this angle right here. That's 41 degrees, 10 minutes.
Okay.
All right. So then delta X and delta Y. Reese, you want to keep going now that you know the angle is here for 41? How would I calculate the delta X?
You do sine
That's right.
of
Sine,
41.
so 41 degrees, 10 minutes. And this would be 411.72 times the cosine of 41 degrees, 10 minutes. So you could see that it, sometimes it's confusing on where the angle is. You have to make sure that you're really looking at it detailed. So the delta X, let's see, from D to E, I got 270.98 and I got 309.97. And then Reese, going from D to E, is delta X positive or negative?
X is negative.
Right. And what about Y, going from D to E?
Positive.
Positive. So now we take the D coordinates, which is 478.71 X, and the Y is 860.7, and you subtract the 270.98 and you add the 309.97, and the coordinates for E turn out to be 207.73 and negative 550.20. So the E coordinate is 207.73 negative 550.20 negative. Okay, and now we're looking at going from A to E. And the information that we have for that Roberto, what's the distance from E to A?
588.16 feet.
Right, and what's the bearing? North?
North 20 degrees, 41 minutes west.
Great. Okay, so I'm going to draw my triangle going from E. So where does this 2041 go?
At angle E.
Okay, so let's see. It's north, west. Yep. So it's 20 degrees, 41 minutes. So here's my delta X. Here's my delta Y. So delta X Roberto? How do I find delta x?
You take you take the feet, 588.16 sine of
Right.
2041.
And then delta y is 588.16 times the cosine of 2041. And I got 0.0, no. I got 207.7 and 550. 550.26. And then Roberto, going from E to A in the X, is it positive or negative?
That's negative.
Right. And then what about Y?
Positive.
Positive. Okay. And the coordinates for Y in the X was 207.73 and negative 50.20. And then I'm gonna subtract 207.70 and add 550.26. And I got I got 0.03 positive. And here, this was 20. I got positive 0.06. So the coordinate of A turns out to be 0.03, 0.06.
Should be 0, 0 though, right?
It should be 0, 0, right? Okay, how is everyone so far? So we looked at this traverse and we went all the way along the traverse using the distances and using the bearings to come up with the coordinates of all the points. So in the end, we got the coordinate of B to be this, we got the coordinate of C to be this, we got the coordinate of D to be this, the coordinate of E to be this. And because we're doing surveying, we always come back and close, and we have a coordinate of A of this, but it should be 0, 0. Okay, now I know you guys got little different numbers, but in the end, you are going to have what's referred to as a closure error. So this is where point A was, and it had a coordinate of 0, 0, right? A initial is in this location, but where is A final? Tarek, where is A final? How should I draw this? It's 3 over and 6 up. So A final.
Positive 0.03 in the X direction.
So this is the
And
amount that is
positive-
off, right? It's off when we got the final coordinates of A, it was over 0.03 in the X and it was up 0.06. So let's do A initial. Let me just write this differently here. So right here is A and it's 0.3. So what is the real error? My error, you could say, is 0.03 in the X and 0.06 in the Y, but really the distance between the two, really, what is the closure error? How would you calculate what this distance is here? Amani.
We can use Pythag.
Right. So it's 0.03 squared plus 0.06. 6 squared and under the radical, and what does it come out to be?
It's gonna be 0.0671 is what I got.
Right, so, and we want to bring it to 2 decimal places, right? Because we've always used 2 decimal places. So it's that.
Mhm.
Does everybody see that's the amount of closure error? Ashton, in surveying, how do we report error? We don't do percent error. How do we calculate error?
The reciprocal, 1 foot over certain footage.
Right, so it's 1 foot over X feet, right? So let's see. We got an error of 0.07 error. And how many feet did we survey? How much did we survey? Look at this. We have all these distances, right? So we started at A, we went to B, C, D, E, and back to A. And this is all the distance we surveyed. And if you add all that up, the total distance was about 3,300 feet. So what error, Ashton, what error did we get? We got a 0.07 error in measuring 3,300 feet. And what does X turn out to be?
My calculator says 2.12 times 10 to the negative fifth, but that doesn't sound right.
Okay, so let's do it again. Try it again. 0.07 divided by 3,300. And you got
Yeah,
a point? Did you get a 0.2?
2.12 times 10 to the negative fifth.
Okay, then you have to do the reciprocal. Press the reciprocal button. And what did you get?
1 foot per 47,142.86 feet.
Right. You got a 1 foot error in 47,000 feet. A 1 foot error in 47,000 feet. Does that seem like a good error? How about if the allowable, they allowed a 1 foot error in 10,000 feet? Would this 1 foot error in 47,000 feet be okay? Ashton, you want to say it?
Oh, I had missed that last part. What was the allowable?
Let's say the allowable is a 1 foot error in 10,000 feet, and we got a 1 foot error in 47,000 feet. How did we do?
Yeah, that's really good.
We did good. Okay, and we could
Would it-
go back. Question?
Would it be accurate to say that you're roughly 4.7 times better than the allowable error? Is that wrong?
Yeah, I think so. But that's not how we would say it in
Okay.
surveying or civil engineering, but you're right. You know,
Okay.
if you're comparing these two numbers, right? 4.7 times, yeah. But yeah. So now if we went back to our notes from, was it a couple of weeks ago when we looked at allowable error? Let's take a look at that. Let's see.
Is that error gonna get distributed like it, like
Yep.
the, okay.
Yep, that's the next step. Okay, let's find. Okay, so it's in the packet. You see when are you watching my screen or no? I gotta show
We
you what I'm
can't
doing.
see what's going on.
Yeah, let me show
in the
you.
screen.
Watch this. I'm gonna share my screen. And right now you could see the packet, right? I'm gonna open it up and watch as I change my pages. Can you see the pages up on the top? Can you see page 5 of 81? 6, it jumps back. Isn't that weird?
It does that a lot,
It does?
for me at least.
Okay, so let's go down. Let's see, it's about page 26. Let's see if I could just put it in. Oh, no. Now it's not even letting me, okay, let's try that, 26. No. Wow. All right, well, we're at the problem. But I wanted to go back where we looked at error. Okay. So let's take a look. So first order, remember this is the strictest, and we said it was dams and tunnels and military things, right? And this was smaller construction projects. And we're looking at a one part error in 10,000. So we're almost at a second order class 1 of 1 part error in 50,000 because we got a 1 foot error in 47,000. So it's pretty good. Okay, I'm going to stop sharing and go back to this. So does everybody see what we did, right? Let's go, let's look. So 1 was compute the interior angle of point A. We did compute the bearing of all these and then check the bearing. We did determine the coordinates of point A, B, and C and determine the closure error. And we did. And now the next part is we have to distribute the error, but I want to find something else in a little bit. So now another thing I want to tell you, and I'm going to go back in my notes to when we talked about the X comma Y. Remember that this has to do with our east. Our positive X is east and positive Y is north. So let's take a look at this. We got a coordinate of B of 457 and 334. And remember, this is east and north, right? And this is east and north. So the fact in C, we got a negative. Where is it actually? Is it in the north or in the south?
South.
South, correct. Let's see, D, we got, this is the east still, it's still on the east. And this is north, but it's a negative north. It's really in the south. And then the easting, I mean, for point E, we got, this is the east again, and this is the north. We're still in the negative. And does it make sense? Let's take a look at our picture. If the origin is here, this would still be positive, but look at where C is. This was drawn to scale. C is actually south because this is the coordinate and this is north, southeast, this is south, and this is west. So A is 0, 0 on the origin, B is in the northing and the easting, C actually is in the east and the south, D is in the east and the south, E is in the east and the south, and then we come back to the origin. Everybody understands that? Okay. So in surveying and civil engineering, we really don't like to have negative numbers. So what could I have done with assigning a coordinate to A that I could have made it so I would have no negative numbers? Where could I have put my origin? Edgar. I don't like the idea that I'm getting negative northings for C, D, and E. Where should I have put my origin instead of putting it here? Agree. What?
I'm not fully sure.
Well, we probably would have wanted to have it lower, right?
So
Right? So
it would
maybe
be-
we could have made the origin down here, so everything would be positive,
Oh, okay.
right? We could put the origin down here. So I started with the origin at 0, 0, because coming from math, we're very comfortable with an origin being at 0, 0, and we started with point A. But normally in surveying and civil engineering, our start point, we usually assign a coordinate of something like 10,000, 10,000. Or maybe 5,000, 5,000. Does that make sense? So I chose a start point. I gave a coordinate of A of 0, 0, because I wanted us to really see what the numbers are as we're moving around. But I want you to know that in surveying and civil engineering, our starting point always has an elevation of a positive number. So when we go around, we're always working in positives. Then, because can't you see a reason that we would make error? Like, look, every time we did each triangle, we had to make sure that they were positive or negatives, right? And there's quite possible we could have made a mistake and forgot to put a negative in. So in surveying and civil engineering, our starting point always has a higher coordinate. And then once we draw it up, I don't remember how it looked. And so we have, this would be not the origin, but it would be 10,000, 10,000. And then what we do when we come back after we have all the data from the field, we come back into the office and then we find out what is the California coordinate and we place this over that. Does that make sense? So, let's see. Okay, this is our California coordinate system. Here is my X and here's my Y. And it's really northing and easting. And this is my plot of land that I just surveyed. And I gave it some arbitrary coordinate for the first point so that I could have all positive values. But then what I do is when I come back to my office, I take the California coordinate system and I move this point. Oh, this point really isn't 10,000, 10,000. It really is right here or right here. And then I overlay them. Those of you who have taken AutoCAD, you know how you could create layers on AutoCAD where you could put points over each other? That's what you do when you come back from the field. But out in the field, to minimize the number of error, you always start with some arbitrary high coordinate of the starting point. And then when you come back in the office, then you plot it right here. So it's as if you drew up your property in your house and you just drew it using arbitrary numbers. And then you say, oh, I'm on Old San Jose Road. So I'm actually going to move my whole property and place it on Old San Jose Road to where it's supposed to be. Does that sound a little bit clearer? Okay, I'm gonna
So then
check
you would
in
have
with you
to,
guys. Hang on a second. Let me just. Okay, what was the question? Tarek,
so
was that you?
everything, yes, it was. So everything you calculated in the field, you'd have to have one more calculation, right? You're changing
Yeah.
the origin again.
Right, but it's not really a calculation. You're
Okay.
gonna know what the coordinate is of A, and you're just gonna place it using AutoCAD and put it right where it's supposed to be. Daniel, do you want to talk a little bit about this? I don't know if you've worked much with surveying. No, okay. Okay, so you're probably usually just working with plans of buildings and grading plans and stuff. Okay. I'm not hearing you.
Oh, sorry. I have overlaid things in AutoCAD like you're talking about, but yeah, I haven't done much surveying, so.
Okay,
But so
Right.
so you're saying you would do basically you do all the calculations at the when you get back to the office, though you just know where A is and you overlay it, so you're not redoing all the calculations, or do you do them in the field?
you always do all your calculations in the field, always.
And then
Because the field could be 3 hours away. And you just
Right.
drove 3 hours.
Yeah.
You want to
That makes
stay
sense.
on your site until you're sure of all the numbers you have. And once you're comfortable, you take down the equipment, you go back to the office, and then you just move the property to the location it is. Okay? So the reason I'm telling you this is because we started with an origin at the first point, because I wanted to give you a feel for the math. But normally in surveying, we always start with a large number for the beginning point. Okay,
would there be any reason for you to find the California coordinate of each point that you found? I mean, I guess that's kind of what the question I was getting at. Like, you
my
do all your
my experience is you just lay your property over it, and then if you wanted, you could find the California coordinates.
Right. Okay. But you don't necessarily do that unless there's some reason to.
Yeah.
Okay.
Do you have a surveyor office, but it's Laney, right, Daniel? County and Jose. There's no license. Oh, you know who you could talk to? Greg.
Yeah, Greg is the
Jones.
licensed surveyor. Yeah. He's the or he's the like county surveyor now. Yeah.
Yeah, and Greg Jones actually was an alumni of Cabrillo's program. I don't know if
That's
you knew
right,
that. So you could talk to Greg. You guys, both of you, Daniel and Jose, why don't you have a discussion with Greg about coordinates and starting out with high numbers and what they actually do when they come back in the office. I mean, it would be great if you knew where the point was in the California coordinate system before you go out, but you don't always know that.
Right.
So you just pick an arbitrary number and you pick high numbers. You never deal with negatives.
I have a question.
Okay. Yeah, Beth.
So I get like picking large numbers so that you won't have like negative coordinates, but you're still going to have like delta x's and delta y's that are negative, right?
Correct. You'll still have, oh yeah, good point. That's right. That's a really good point, because I was showing you the negatives and the positives, right? Yes, you are still going to calculate positive and negatives in the delta. Definitely, you will. So you do have to be careful of that. So yeah, thanks, Beth, for pointing that out. Okay. The other add-on that I want to show you is that I want to give you a term. Maybe where should we, let me see where I would like to write this. And of course, I'll scan this at the end. I think I'm going to do it here. Okay. So on this page is where we drew it again when we were about to do the calculations, and I was showing you that X and Y is east and north. So when we write it as a coordinate, we're still going to put east comma north. But typically as a surveyor, we're talking about northings and eastings. So on a quiz or something, I might say, what's the northing and easting? You have to have your head on that you're not going to give me the east first and the north next, right? You have to know that we're transferring from X to Y, which is easting and northing, but often when you look at data, you'll see the northing first, but it wouldn't be in parentheses like a coordinate. The other thing that I want you to know is when we are looking at, if we're going from one point to another, and this is my change in X and this is my change in Y, the change in X in surveying is called departure. And the change in y is called latitude. It has nothing to do with latitude and longitude. That's something different. But it's important for you to remember these terms. Okay, that delta x is called departure and delta y is called latitude. And even though I'm still on the northing and easting coordinate system, which is on a horizontal plane, the way I remember is I think of an airplane. When you're departing on a plane, you first drive horizontal and then it goes up in the air. That's just how I remember it. But remember, this is not a vertical plane. This is a horizontal plane. That was just the way I initially learned it. So we're still looking at a horizontal plane. Departure is east-west. Latitude is north-south. It's on a horizontal plane. We're not talking vertical, but the way I remember that the term departure is this, is on an airplane, you first go this way and then you go up. All right, so I'm giving you some of my tricks, but you might have better tricks. Okay, I think we need another break. What do you guys, let me pause. Okay, rather than write the table out, I just pulled it from the lecture packet. And this is a 5-column table. The first column represents the lines of our traverse that we did. The next 2 columns represent the latitude, which is northing and the north and south, and the departure is the east and the west. So we knew that going from A to B, we calculated that the change in y, right? If it's north and south, we're talking about the change in y. The latitude is a change in y. The departure is a change in x. From A to B, we had a positive 334.91 and we had a positive 457.94. Then BC, we had a negative, we calculated a negative 505.48 and a positive departure. Again, latitudes change in y, departures change in x. Then CD, we had a negative change in latitude and we had a negative change in departure. DE, we had a positive latitude and a negative departure. And EA, we had a positive latitude and a negative departure, right? So if I go back, is everybody looking at these numbers and comparing them? We calculated the change in X and the change in Y going from A to B. We calculated the change in X and change in Y going along every single line. And what I did is if they were a positive latitude, positive change in Y, I put them in this column, negative change in Y here. And then the departure, if it was positive, if it was negative. So for this, I added up all the northings and I got 1195.14. And then I added up all the souths, 1195.08, and it came out that there's an error in latitude of 0.06. And then I added up all the positives, change in X's, and all the negative change in X's, and I have the change in departure was 0.03. And does that make sense? Where did we see this number, 0.06 and 0.03? I really don't know where we are. Lori.
The difference in the code.
Not in the closure error.
Right, it was our closure error. It was the difference in the coordinates, right? That we got. So this was just another way to look at that in addition to doing coordinates. So now it means that we have a 0.06 error in latitude and we have a 0.03 error in departure. And we're going to have to spread it out as Daniel had predicted. So how do we do the correction? We do it very similar to what we do in leveling. So it's really a ratio of the correction in a line is over the total era. So maybe we could write it this way instead. The era in a line, in a specific line over the total era in latitude is going to be the length of that line over the total length. Right? Very, very similar to what we did in leveling. So that means this is the error. This is what we're going to correct. We're going to correct line AB in latitude by multiplying the total error by the distance from A to B over the total distance. So the correction in latitude for AB is 0.06. The distance from A to B, the total distance, comes out to be this. And then I use my rounding and surveying. Correction from B to C is the total error. The distance from B to C over the total distance, and I get this, and then I get this, and then I get this, and then I get this. So we're using this equation. So the correction, the error correction over the total error is going to be distributed by the length of the line versus the total length. Again, we're saying the longer the line, the more error I probably got. So let's take a look then.
Are we just looking at X or Y separately though, or are we?
Yes, yeah.
Okay. Or
So this
sorry,
is-
yeah,
Yeah, this is all the latitude, and I showed you the exact equation.
right.
And then I did the same exact thing for the departure, but I didn't rewrite the whole equation again. I have to do it separately because I have an error in latitude that's different than the error in departure. Even if these two errors were the same, I would. No, if the errors were the same, I wouldn't have to do the calculation twice because it's all based on length,
Right.
right? But the error is different. Okay, so now let's take a look at this. Everybody's with me? I know it's late, huh? Mackenzie. When I add up this number, it comes out to be 0.14, right? And when I add up this number, it's 0.08. So in order for these two numbers to come closer together, what do I need to do with this number? Decrease or increase? And what do I do with this number? Decrease or increase? Kenzie, are you here? No. Olivia, you're here?
Yeah, you
Okay.
would want to decrease the first number and increase the second one.
Correct. Because we're all looking at absolute value, right? We want to bring this 14 closer to the 0.8 and we want to bring the 0.8 closer to the 14. And then Reese, what about these? This is 0.83 and this is 0.8. What do we want to do to this number?
You want to bring it down,
And you want to,
and then you want to increase that other one.
right. So if a number, if one of these lines has a positive northing, we want to get that number down. If it has a south latitude, so if it has a north latitude, we want to get the number lower. But if it has a south latitude, we want to make the number higher. Same thing here. If the line has a positive departure, this is too high, we want to bring these numbers down, and these need to come up. So let's take a look at what happened. So here is, oops, hang on. So what is the adjustment that I calculated? Let me bring this up. What is the adjustment I have to correct for AB? Roberto? the correction for AB is what? 0.01, right? You here? Roberto, you here? Okay, Tarek. The correction for AB is 0.01, right? And we said
Right.
that this one's too high, right? So when I correct it, what will the number be in this table?
334.90.
Yep. And here's my corrected table, 334.90. Okay, let's do the next one. Amani, the correction for BC is also 0.01. Whereas BC is over here. What do I want to do to this correction?
I'm gonna add, so it's gonna
Right.
be 505.49.
Exactly. And then let's do CD, the correction is 0.02. Ashton, the correction is 0.02 for CD. What do I want to do?
You would you add the 0.02 to that one?
Correct, because you want to bring these numbers up. So here's 689.62. And then Beth, for DE 30997, the correction is 0.01. I'm looking at the number right here. It's 0.01. And here
You want to
is,
subtract that.
I want to drop it. I want to make it smaller. So it'd be 309.96 because it's 01. And then EA, Connor, EA, I got a correction of 0.012, and EA is in the northing. What do I want to do to this?
You want to subtract it.
Right. So in the end, I made all my corrections to the latitude, and now these numbers come out closer. So I basically have adjusted it. And remember, this is the latitude is the change in Y, and the departure is the change in X. So then the same thing. Here I have a total error of 33, but from rounding, I'm only going to put 2 corrections on here. So Dan, for BC, what do I want to do with this number?
Looks like you need to subtract 0.01 from it.
Correct. And then Edgar, what do I want to do with the CD? Edgar, you're here, right?
We were subtract, right?
No, we want this number to be higher. Right? So we would have to add.
Oh, okay.
Okay. So in the end, you're adjusting the 633.89 to 633.88 and the 613.12 to 613.13. And when you add up these two numbers, it still doesn't line up. They're not exactly the same numbers, but that's the best you could do in adjusting, because there's always going to be some kind of rounding error. Okay. So what we did is we went around the whole traverse. We went around the whole traverse and we determined what the change in X and the change in Y, the latitude and the departure were. And then in the end, we did a correction based on a correction very similar to what we did in leveling. Okay.
Does that always happen if you have an odd error number that they don't quite match up after you distribute?
No, it's all based on rounding, because one of them could have had a 0.02 and one could have had a 0.01. Right? So then it would have come out even. So it's just how the rounding is. But as long as we follow the process in surveying, we're fine. There are some errors that are okay. So even though we got an allowable error, we still did distribute that error, even though our error wasn't so bad. Okay, so if we go back to this whole problem, 5 was determine the latitude, the departure of each of the lines, and then find the error and adjust it. So we did that. Okay, the last thing we do is compute the area of a traverse. And that's fun. And we do this twice, this process that you're going to learn. We do it twice in our class, and you're gonna see it in the future too. It's called the double area method. But let's just take a look at the picture to begin with. They want to know what the area is of this traverse. So here are a few ways you could calculate the area. One, break it up into a bunch of triangles and squares and do geometry. Another is you could draw this in AutoCAD and go into the area command and click on this point, this point, this point, this point, this point, and go back to this point, and it'll tell you what the area is. There's also something called the planimeter. It's probably never used anymore, but when I was starting in surveying, I mean, civil engineering, we use it. It was this device where you set up the scale of your drawing on this little device. It looked a little like a compass, but it had and then you would just move the spot over and it calculated the area. But the coolest way to measure area is to do it by the double area method. Actually, I'm not going to write it. It'll just be another page to scan. It's in the packet. Okay, so let's take a look at this. This is called the double area method. So what we do is we put the northing over the easting, the coordinates. Remember, A started at 0, 0, and there was a little error, but we don't have to worry about that. Joanna, what does this fraction represent?
I was gonna say rice over run, but horizontal over vertical. No, vertical over horizontal.
Okay, so it is not, we're not dealing with vertical at all. This all has to do with the horizontal plane. You meant the change in Y over the change in X.
Yeah.
But actually, it's not the change in Y over the change in X. Look back at your notes. What is 334.91 represent? Take a look in the notes. Let's go back. Talking about point B. The coordinate of point B is 334.91 and 457. So what this is that we're looking at is the coordinates. This is the coordinate of B. This is the coordinate of C, the coordinate of D, the coordinate of E. And notice you always have to start and end with the same point because you have to do a loop. So we want to find an area of the traverse. We start at a point, we have to end at a point. And then points B, C, D, and E, and we put the coordinates and we put the northing over the easting. And then what do? And this isn't called cross multiplying. This is something that you've seen in determinants. You multiply the numerator by the denominator and then add it to the numerator by the denominator, then add it to the numerator by the denominator, then plus numerator to the denominator plus numerator to the denominator. So that's what I did here. I multiplied all these together and then I came back the other way. Numerator by denominator plus numerator denominator, numerator denominator, and I did all that. So what you do is you go down on slashes, you multiply them together, and then you subtract going backwards, and you come up with a value. And this is the double area of this traverse. And because it's the double area, you take that number, divide by 2, and you get the number of the area of that traverse. Isn't that cool? As long as you know a coordinates of all the points in a closed loop, you could do the double area method to find out what the area is. You start with the same point that you end with. You do the crosses this way, subtract the crosses that way, and then divide it by 2.
And normally you'd have some arbitrary big number.
Right.
That's
That's a good point. That had our A been 10,000, 10,000, the math would have been more longer, right? but I'm sure you guys could figure out how to program the coordinates in the calculator and have it crunch it out for you. Okay. So now we did every single thing in this traverse. Let's now look at, let's look at, let's look at the homework. Okay. Okay, I'm going to share my screen. We were going to, those of you that were going to be in person with me tonight, we're going to check the total station batteries, but we're okay on them. We charged the other half, so we'll be fine on Saturday. Again, I'm hoping to go out there, on Friday, the campus. Okay, so let's look at the Traverse homework. I'm going to open it up. Okay, so we have the same kind of thing. We have another 5-sided traverse. I'm giving you 4 angles, interior angles, and I'm giving you the bearing of the first line. And what does it ask you? It asks you to find the interior angle at A, and it asks you to find the azimuths and the bearings for all the lines. So you're doing the same kind of thing we just did, but I'm adding in finding azimuths too. And that's question number 1. Okay. And then question number 2, now I'm giving you a traverse that has only 4 sides. I'm giving you all the bearings and I'm giving you all the lengths. And I want you to draw it to scale. If you want to use AutoCAD or any kind of CAD program, you could draw it, or you could draw it by hand. Okay. So of course, if you're going to draw it by hand, before you start drawing it, make a quick sketch as what it's going to look like so that you can make sure you fit it on the paper. And what's nice about drawing it to scale is you actually could measure angles to check yourself. I'm asking you to find all the interior angles now. I want you to find all the coordinates. I want you to find the closure error, or it's also called linear misclosure. And I want you to check it with 3rd order class 1, allowable. I want you to find the area of the traverse, which you do by double area method, and then find the latitude and the departure and balance the latitude and departure. So you have 2 problems, but there are very long problems. And they're very similar to the one we just did in class. Okay, I'm going to stop sharing. Okay. So we are finished with today's lesson.